Hello, my name is Lattanzi. I'm going to be presenting my Lab 5 demo today. It is the ALU circuit, which takes care of addition, subtraction, and multiplication all in one, using also a tri-state buffer to change between the three. Okay, so sharing my screen, we are going to go through first. We're going to go through the design of the ALU. Let me get my pointer up. Okay, so the design of the ALU is there's an 8-bit input, two 8-bit inputs coming in. They are both computed. So one is computed in addition or subtraction, one is computed in multiplication. And this function choose, which goes through the tri-state buffer, is going to determine how the circuit runs. So if this is set to 0, you'll see this will come through, become a 1, and the tri-state buffer allows this value to go through to the output. This is the same thing here. If it's set or opposite here, if it's set to 1, this will go 0, this will be 1, and it will let the addition subtraction here. There is another input where you decide addition or subtraction. So setting to 1 is subtraction, 0 is addition. You see another output here for overflow. So going into what is going on in these blocks, first, the adder subtractor is right here. I went over this in the last video. We were coming in with 8 inputs each here. They're going through and they are being added down. If there is a carry, it's brought through here. Next value added with the carry down. Next value added with the carry down. Overflow is detected. The only difference with this one is that right here you will see that there are 8 outputs for this one. Here's the multiplier design, which we'll go more into. This line highlighted is the longest line possible going through, which will take approximately 170 nanoseconds of each level it has to go through is 10 nanoseconds. So then we go through this here, and just starting in, a value comes in. It's the first 2 multiplied or ANDed together and multiplied, come down, first value. Next comes in, same value, goes through with a full adder added together. We're pretty much, the whole process of this is repeated addition to create multiplication. So it keeps going, full added, full added, full added, and then we get out our 8 inputs. So proving that these 3 are all working, first, we will look at this where the end time is set to 40. We're just looking at these 2 columns, but I'll just be talking about this one. I'd like to note that you can see the adder subtractor is set to 0, therefore it is addition. You can see the function is set to 1, so it creates addition with the tri-state buffer. You can see these 2 values are successfully added here to get the output we are looking for. This next one, same settings for function and addition, but we are seeing that there are much larger values here, which will create an overflow of over 8 bits. And you can see our function detected that overflow right here successfully. So that's proving the functionality of the addition and the addition overflow feature of the circuit. Next, we are looking into the subtraction. So you can see now the adder subtractor is set to 1, which is creating subtraction. You see we're successfully subtracting these 2 numbers to get out a correct value here. Okay, here we're seeing another example of subtraction set to 1, just a smaller, another example value here, end time still 40 seconds. So it's this top one minus this one, and we're getting this. So we're looking at these 3 are the kind of groups. So output here, no overflow detected. All right, so now looking into multiplication successfully, I'd like to see this. Okay, so this adding thing does not matter. The function for deciding is set to 0, so that means that multiplication is going to be taking place between these 2 numbers, and we can see they are successfully multiplied together here, which is 2 times 3, 6 in decimal. Binary, these are both in binary, but that was just explaining in decimal for those who do not know. End time 40 seconds, we are multiplying a little bit of larger 2 numbers now. But once again, we are getting out our correct output here with the multiplier. Overflow is not going to be detected. It's because of multiplication, but the multiplication is done correctly. Add or subtract doesn't matter. Function set to 0. Beautiful example of multiplication here. Okay, so once again, I'm Jack Lattanzi. I am in lab section 5, ECE102, 9 a.m. On Fridays. I just presented to you my full adder combined with adder, subtractor, and multiplier circuit. Thank you for watching, and let me know if you have any questions.